All right. You've got your data from your lab on Friday, so hopefully you have that. If you don't have data for some reason, or your data is bummy or whatnot, you don't like it, it's lame sauce, you can use the data that's on the left-hand side of the board. It's also a picture on here for those who are watching this online and don't have it. So you should have an initial data and you should have a final data point for all of them, and it should be measured in percent oxygen. Okay? If yours didn't come out, or your group messed something up, or for some reason you used the wrong sensor, or you forgot to record the initials, something like that, you can use this data right here. So for all of them, I've got, for the temperature, I've got normal, hot, cold. For pH, I've got neutral, I've got basic, and I've got acidic. So I've got a starting point and I've got an end point for all of this. So you need this to get started on where you're going to go next with this. Okay? So there's also some on the left-hand side if you're taking a picture of this. Okay? So now what you're going to do with this data. Let's say I'm looking at this and I'm going to say that we're going to go with temp. Okay? So we're looking at temperature here. So let's say for normal, hot, cold. Okay? So I've got all of these things right here that fall under temperature. I've got to first calculate out what is the rate, or what is the difference, I'm sorry. Difference. Okay? And difference is going to be measured as, to calculate difference, it's going to be final minus initial. Okay? So let's say for normal, I calculate it out, and I calculate out the difference is going to be 4.5%. That means I may have started at 20% and I ended at 24.5%. So my difference, 24.5 minus the initial, which is 20.0. Let's say my hot is going to be 0.3%. Okay? And my cold is going to be 0.6%. So those are my differences. All right? So when I did the final minus initial. Now what I need to do with that data is I need to calculate out what is going to be my rate. Okay? And my rate is going to be percent O2 per minute. Okay, so that's the rate that we're going to measure in. So let's say for my data, that's why if you look at my data over there, I have the 3 minutes circled. So what I'm going to do is I'm going to take what is my total difference divided by the total number of minutes. So I would do 4.5% divided by 3 minutes. So that's going to come out to my rate for this is 1.5% O2 per minute. So it gained 1.5% oxygen per minute. My rate for hot would be 0.1% per minute. All right, and my rate for cold, or let me see what I had here. Yeah, my rate for cold would be 0.2% per minute. Okay, so you see how I got all that? So this would be like my data table that I'd have here. So okay, it'd look like that. And I calculated out my rate. You
keep kicking me.
I haven't touched you once. You're kicking the crossbar on the table.
I'm not.
Okay. So now what I have is I've got to graph this. Okay. So here's this graph. Okay. And on this graph, I need to have a few things. I'm going to be graphing the rate. So biggest, most important thing that a lot of people forget, you need a title. Okay. And now what I'm going to put down here is, let's say that this is going to be temp. Let's say this on the left-hand side would be rate. Rate. And you need to tell me your units. All right. So what was rate measured in? We measured it in percent O2 per minute. You need to have all of this identified. Okay. And so for temp, let's say we had normal, hot, and cold. Okay. If I'm looking at this data right here, so I'm looking at this, I'm looking at this, and I'm looking at this. If you notice, it's not continuous. I'm not measuring trend over time, so I'm not measuring what was it at 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes. Therefore, which kind of a graph would I make? Would I make a bar graph or a line graph? I'd make a bar graph. So, for instance, I would then graph this. And so now I might have one bar goes like this. I know. Another one might right here, might go to right here. And then another one might go to like right here. Okay? So I've got a bar graph for this. So here's the thing though. Now that I look at this, what was this graph for? It was looking at temperature. Okay? Is that all our experiment tested? No, we also had one for pH. So I need to do this whole process again for pH. Okay? So when I look at everything that's required for requirements, come on, you can do it. I believe in you. There we go. You're going to need 2 data tables showing me the the difference and the rate. One for temperature, one for pH. You're going to need 2 graphs for temperature and pH. They must have their the titles, so x-axis title, y-axis title, entire graph title. You must have units, you must have labels, all that stuff. And then finally, 2 claim evidence reasonings, all right? On that claim evidence reasoning, you need to discuss and identify a bunch of different things. So for instance, in this one, our enzyme. So we looked at our enzyme on this, and we said our enzyme was going to be catalase, all right? And so on there, you've got that. You'd say, okay, so for our reason on this, we had this enzyme catalase, and it breaks something down to our substrate. What was the thing in this lab, this substrate, that got broken down? Hydrogen peroxide. So I had enzyme, my catalase enzyme, and I had hydrogen peroxide. They combined at that active site, and it broke that down. And so when it broke it down into water, and it broke it down into oxygen. So now you've identified those products. And then you can talk about the pH and the temperature. So you could say, when we increase the temperature, looking at your data on there. So for instance, when I increase the temperature for hot, notice what it did to our rate. Our rate went from, oh, that one was all bad news bears. Okay, I know. Our rate went from 1.5% down to 0.1%, so it decreased our rate. And a big reason for that would be because you denatured that enzyme. You denatured that enzyme because you changed the shape of that active site. When you change the shape of that active site, that substrate can't fit in there, and now it can't break it down into oxygen and carbon, or into oxygen and water. So that's why your oxygen percentage went way down. The same thing for cold. You slowed down that rate based on that data, and so because of that, you probably slowed down the molecular movement. So you're going to give me your claim evidence reasoning for both of those, looking at that. So like I said, the things you must discuss and identify. You need to discuss the enzymes and identify what are the enzymes of this, what was its job, what was the substrate in this, what was its job. When I broke down that substrate, what did I produce? When I denatured something, what could have caused it to denature? Since the whole purpose of this was how do temperature and pH affect this thing, what did they do to it? All right, did they denature it, or did they just slow molecular movement down? Because remember, heat, obviously you know that it does it, because think about when you cook a steak. But do you cook a steak when you put it in the freezer? No. So did you denature it? Interesting. Think about that. If you're looking at your rate, if your rate slowed down, yes, it slowed down, but you didn't cook your steak. So what did you do? All right, so you're going to write about that in there. Based off your rates, looking at this, so if I were looking at my data table right here for normal temperature, hot temperature, and cold temperature, which one is the most ideal based off my rate? Normal. So that's what it's talking about right there, is looking at your data from all of these. You're going to you're going to make your claim on which one had the most ideal conditions. Is it a pH of 7? Is it a pH of 13.5? Is it a pH of 1.5? So all of that, okay? So you make your claim. Your claim is going to be high temperature does this, cold temperature does this, high pH does this, low pH does this. What's your evidence? Your evidence is going to be your data table and your graphs, all right? So that's why I was saying you need to have, right here, you need to have a data table showing the difference and the rate, temperature and pH, graphs for those with titles and everything. That's going to be your evidence. And then finally, you need to do your reasoning. That's going to show me that you actually know what you're talking about. Okay? Are there any questions on this? So this kind of sums everything up that we went over the last few days with all of that. So if you need help calculating out all that, if you need help making your graphs or anything, calculating rate, any of that, please let me know. This is going to be Friday, okay, for your plan evidence reasoning. Yep. So there's 2 data tables you need, there's 2 graphs you need, and there's 2 claim evidence reasonings, or 2 reasonings you need. Okay? Because we did 2 experiments in this thing collectively, we did 1 for temperature and 1 for pH.
Is it a joke? No, it's not. No, it's nothing
So,
related whatsoever. I'll talk about it later.
Real quick, I'm going to give you about 3 to 5 minutes to share your data with your group members because a quarter of you were not here Friday.
Hi.
So if you were not here Friday, please get your data. That way you have everything and you can't come to me Friday and say, well, I never got data. Yes. So I'll show you right here. Nope. So someone asked how to find the rate. Okay. I'll do it with some of my data that I have here. Oh, I'm recording on here. I'll do it on here.
Yeah, I was like, you're still doing it.
Yeah. Sorry, I realize I'm still recording.
Look at Snapchat.
Okay. Hey guys, cut the talking real quick. Someone asked how to calculate rate, and if they have a question, that means there's more people who do. Let's say when I'm doing this, I have my initial was 20.6. Let's say my final was 24.2. So to calculate out, first I've got to calculate difference. Before I can calculate that, I've got to calculate difference. And we said up here, difference is going to be final minus initial. So I would do 24.2 minus 20.6. Minus 20.6. What's that come out to? Oh, that's 2.6. 20.6. What's that, 3.6? 3.6. So right now we know my difference is 3.6. So that means when I started, I was at 20.6% oxygen. When I ended, I was at 24.2. So overall, I gained 3.6% oxygen, Sebastian. I gained 3.6% oxygen in those 3 minutes. So now what I'm going to do is, I know it took 3 minutes to do this. So I'm going to take 3.6 divided by 3 minutes. And what that's going to tell me is, when I do 3.6 divided by 3 minutes, I get 1.2. So that means I get 1.2% oxygen per minute. Okay? So that means in the 3 minutes that I was doing it, it was gaining 1.2% oxygen per minute for 3 minutes. All right? So right here, what this is showing me on this data table that I gave you this, it said under normal conditions, so when I took it at room temperature, my enzyme gained, so I was producing 1.5% oxygen per minute. And remember, if I break down hydrogen peroxide using catalase, I make oxygen and I make water. We couldn't measure the water, but we can measure the oxygen. So this was making a good amount of oxygen per minute. When I took it and I boiled it, I was only making 0.1% oxygen. So all of a sudden I wasn't making oxygen anywhere near as fast. That means something had to happen to affect that enzyme so that enzyme now wasn't breaking it down as efficiently. Because if it was breaking it down better, that rate would be faster. So a couple groups on their data, what they actually found is when they heated it up, there's 2 types of data for people who heated it up. Those who just heated it up kind of, and those who boiled it and let it boil for like 5 minutes. Because remember, you designed this, so it was up to you on how long you want to do it. So those who boiled it, their rate went down like this. All right? So how many of you had groups where your data went way down for the hot, where it went below your normal one? Any of you? Okay, you guys did. So, did any of you have data where your rate went up for warm? Okay. Do you remember which kind of organism we used that had catalase? We used yeast. Any of you ever made bread? When you make bread, do you put yeast in cold water? Put it in hot water. Yeast like hot water. So, ideal condition for yeast is hot water. So, if you maybe just heated your water up pretty hot and then did that, chances are you just put your yeast in perfect condition instead of actually denaturing it. That's okay. No, that's what I want you to see.